Hey guys, Mr. Blue here with a high quality chemistry educational video. Today we are going to look at what we call excess and limiting reagents in chemistry. So generally, let's look at this particular example here. So if we go to a party, albeit not a very good one, then you would expect, let's say for instance that somebody's bringing the hot dogs. So someone brings the hot dogs and they bring 5 of the hot dogs. But then somebody here has bought the buns. So another friend has bought the buns. And they've only bought 4 buns. Now what can happen there is that we can only make 4 hot dogs. So according to this ratio, basically what we need to do is we need 1 hot dog for 1 bun. We'll make 1 hot dog, So, or 1 hot dog in a bun, should I say. So what's going to happen there, right, is that according to these ratios, we have 5 hot dogs, we have 4 buns, which means that we can only end up with 4 hot dogs in a bun, So this concept here is what we call our theoretical yield. So this one here is our theoretical yield. This one here is what we call our limiting reagent. So according to this 1-to-1 ratio, of hot dogs to buns, then we should have 4 to 4. But what happens here is we have 1 extra 1 left over, which means at the end here, that is going to go through uncombined. And we call this one here our excess, our excess reactant. Now as well here for our limiting reagent. So what this is basically if we had 5 of these, then we would be able to make 5 hot dogs in buns. But we don't have 5. We only have 4. So this means that it is our limiting reagent. It is the item that is limiting the amount of hot dogs in a bun that we can produce. Now the same thing occurs in chemistry. So to do this, what we need is basically to start off with a chemical reaction. So what I've done here is we're following very much so the same steps that we've been doing so far. We can still use our flowchart. We can still use these steps, but there's slightly a few more changes here now. And I've highlighted these in red, to the original instructions that you would have followed. So let's have a look at a question, So for this particular question here, we're going to go, I'll just go a little bit bigger here in terms of my size of my screen. And let's now have a bit of a look at this first question. So what I've got is I've got the reaction, So this reaction involves magnesium plus magnesium plus chlorine gives us magnesium chloride. Now step 1 states that I need to have a balanced chemical reaction. And this one here, luckily for us, is already balanced. So all I need to do now, is basically I need to fix this. So the question states, so now for part 2, we need to find moles of both of the substances. So for magnesium here, what first of all that we have is we are combining these in a ratio. So we're combining these in a ratio of 1 to 1 to 1. So that means that just like the hot dogs and the buns, I have 1 part magnesium for 1 part chlorine gives us 1 part of magnesium chloride. So instead of just talking about hot dogs and buns now, we're talking about chemicals. Now in this scenario, this is my theoretical stoichiometry relationship. But in this one here now, I have 1 mole of magnesium, Now basically that would just look like this. Let's just put that down there. But what I have here, is I have 3 moles of chlorine. So what that would look like instead is that, remember, we have chlorine and they're bonded together. So I have 3 of these chlorines here bonded together. So I have 3 moles of that. Now what we would get over here on the other side is the formula of magnesium chloride. So to make that, I would have 1 of these red ones, the magnesium, and 2 of these, the chlorines. So what I've got the formation of there is I've got the formation of one of those. So I've got the formation of 1 mole. Now, so far, I haven't used these ones right here. These ones here remain unused. They're my unused ingredients in this relationship. Now, we can't make any more magnesium chloride because we've ran out of magnesium. It's finished. So what we end up with is we end up with excess chlorine. Okay? So we've got excess chlorine. And how much excess chlorine? We have 2 moles of excess chlorine. Now this means that, as basically by default, okay, our limiting reagent or our limiting reactant, the 2 words are used interchangeably, is our magnesium. We haven't got enough magnesium to make more of this. And as a result, we would just move this through and the chlorine would move through unreacted. Okay? So, this one here, our magnesium, we would call it as the limiting reactant, or sometimes interchangeably, you'll also get it called the limiting reagent. Okay? So that's an example there of how to do that. Okay? Really, really simply. So our theoretical yield, or our yield, is only 1 mole. Okay? Because I could only make 1 mole of this magnesium chloride because these 2 went through in excess. So let's now have a look at another question. Okay? Let's have a look now if we had 1 gram of magnesium and 1 gram of chlorine. So I'm going to just basically keep the same chemical reaction, okay? But I'm just going to make this a little bit bigger, if I can, or not, okay? So let's now have a look at this. So I'm just going to get rid of this, okay? And we're still using exactly the same chemical reaction. But this time it's a little bit trickier because we haven't been given directly moles. So what I need to do is, according to my steps, going back here, okay, I now need to, I've got my balanced chemical equation. This time for step 2, I need to find the moles of both of those reagents, or both of those reactants here on my left-hand side. So let's do that now. Let's have a look at them, okay? So what I've got is I've got 1 gram of magnesium. So for this one here, okay, I'm trying to find the amount of moles, and I've been given a mass. So I can go moles equals mass divided by molar mass. I'm here, trying to get to here, okay? So what I'm doing there now is I go 1 divided by the molecular mass of magnesium, which is 24.31. And that there is going to come out at 1 divided by 24.31 equals roughly 0.041. Okay, now what I've done is I've calculated moles for this reactant. Now I need to also calculate moles of this reactant and see which one we have less of. So now we're going to go, we have 1 gram of chlorine, but what's changed this time is the molecular mass. So I've got 35.45 times by 2. Again, I'm going to put that into my calculator. And the answer there is 0.014 moles. Okay? So what this means, okay, is that I have identified, I've calculated moles for both of these substances. Their ratios are the same. It's a 1-to-1 ratio. So which moles do I have the least of? Which moles do I have the least of? That's pretty simple, right? Unless you're dyslexic. It's this one, okay? So I have, this one here is going to be my limiting. On the other hand, excuse me, on the other hand, the magnesium is going to be my excess. That pen doesn't work. My magnesium is going to be my excess. Now, using the limiting reagent, so going back here to my steps, using my limiting reagent. So what I need to do is find moles of the unknown substance using the reactant with the least number of moles, my limiting reactant. And this will tell me, okay, that the amount of magnesium chloride that's produced will be the same as the limiting reagent. So on the other hand there, okay, if we move over to here, we're going to end up with N for magnesium chloride, because of this 1-to-1 ratio, will be 0.014, okay, which means that I'm going to have a fair bit of excess, okay. To be exact, I'm going to have 0.041. I'm going to have 0.027 moles of excess magnesium. Okay, so this is an example of how to do a limiting reagent and excess scenario. We're going to look at some more difficult examples after this. Thank you very much.